Alright, so this is the last lecture. I'm going to talk a little bit about Amazon Web Services. So what is it? Um, why do people use it? How do you use it? And then we'll actually go through the lab. So I've done this lab a couple times, but I'm not going to re-record it if I mess up. So you may see me struggle here a little bit, and that'll just be how it be. Yeah, that's just how it's going to be. So a little bit about Amazon Web Services. What is AWS? So Amazon Web Services is the leading provider for remote computing services. So according to Gartner, AWS has 5 times more deployed cloud infrastructure than the next 14 cloud providers combined. So AWS is huge. Fundamentally, they offer businesses and individuals, really anybody who wants to give them a credit card, the ability to run programs, applications, databases, almost anything, load balancers, websites, whatever you want. They have a huge list, as you'll see here in a minute, of offerings, and and anybody can access those, right? And you're just charged for your usage. You're charged by the hour or by the megabyte or the gigabyte or whatever solution you're using. They basically just charge you by your volume there. And so a lot of businesses use it instead of deploying their own infrastructure. So Amazon's core product offerings are EC2 and S3. So EC2 stands for Elastic Compute Cloud, and it's a standard platform as a service offering. You basically rent an operating system. So whenever you deploy EC2, if you just deploy a standard instance, you can select I want to deploy Windows, I want to deploy Linux, I want to deploy a specific version of these operating systems, a specific flavor. Obviously, Windows is going to be a little more expensive because Amazon has to pay licensing to Microsoft just like you would for Windows. You don't have to buy a license or anything like that. Amazon has that taken care of. They just charge you by the hour. So every hour that you have the operating system active, you get a bill for however many cents they charge for the size that you selected. S3 is the scalable storage service. So basically, it's an online file storage service. So you can just upload files, and a lot of times businesses would use it to store data in the cloud, basically. And you can use it sort of either you can attach it to your EC2 machine, which again is just an operating system you've deployed in the cloud, or you can just upload straight from your machine into S3 and download it back. They have a plethora of additional offerings, so they can do routing, they can do application development tools, application virtualization, they can do long-term storage like backups, a ton of things. So companies basically, they pay a set rate based on usage, and Amazon manages all the back end. One of the advantages to it is it reduces the capital costs and has on-demand flexibility. And so a lot of big businesses, whenever they build a data center, cost millions of dollars. And a lot of big companies have millions in hardware spending every year. Amazon basically takes that and moves it from an upfront capital cost to just an ongoing revolving cost. This helps a lot of businesses that may be expanding rapidly because there's quite a large lead time on getting a big set of infrastructure. So if you're trying to get a whole rack full of Dell servers, that can take weeks or months depending on the server that you selected. On Amazon, you can get a fairly large allocation almost instantly, and you can get a really large one within just a few days. If you give them notice, you can get quite a bit of capacity. They sort of pre-allocate that. It's definitely much faster, and you can scale much more cheaply, and so a lot of businesses use it to grow rapidly. Some examples of those businesses, so Netflix. So there's actually an interesting use case or a case study from Netflix, and it talks about their rationale for going AWS instead of keeping their infrastructure in-house. But fundamentally, Netflix experienced some outages, and they realized part of their core business is not maintaining infrastructure. That's not what they're the best at. They're the best at managing content and doing analytics based on that content and getting and producing shows these days. They're not the best at providing low-cost infrastructure the most reliably. And so they outsource that to Amazon basically. Comcast, Pfizer, CDC, NASA, Adobe, all these use it. Supports 600 government agencies and 2,400 EDUs. And whenever I say these use it, basically none of these have probably gone as far as Netflix, where Netflix has almost no infrastructure of their own. Whenever you stream a Netflix movie, you're streaming it from Amazon Web Services these days. These others just kind of use it to expand. So in some cases, you need a lot of computing power as a business, but you know you're only going to use it one time. So New York Times has a case study that we'll look at here in a little bit that talks about how that might be used sort of to expand your capacity as a one-off. So why use AWS? So I talked about this a little bit, but fundamentally it allows for flexible capital spending and allocation, so you don't have to do a large initial capital investment. Startups can access much more compute than traditionally possible, much cheaper. Customers can reduce consumption just as easily. So fundamentally, if I need to pare back, if for whatever reason we either need to reduce costs or we don't have as much compute overhead required, we just give those machines back to Amazon. And it's no charge because we were basically just renting them in the first place. And companies don't have to lifecycle manage infrastructure. So legacy infrastructure, a lot of companies, they have old servers that they're running their things on just because they either haven't or can't get rid of them. This isn't the case with AWS. You don't really care as a customer what age their servers are or really anything about those servers. Amazon handles all that lifecycle management on the back end, and you just see the guest operating system. So fundamentally, they could change out the server that you're running on 5 times through the life of your operating system, and you wouldn't know or care. They handle all that for you. That's what they're the best at, right? So what's a case study real quick? So New York Times. So they digitized 11 million articles using 100 EC2 instances in 24 hours. So fundamentally, New York Times needed to take their backlog of articles and they wanted to digitize and put it online. And so that takes a fair amount of computing power. They could either have made additional investment by building up their infrastructure and hired platform experts, or done MapReduce, basically. That's really what they used, is Hadoop. And so they had a developer learn Hadoop, develop a MapReduce application that went in, and it examined these PDFs, it parsed them, because really New York Times didn't just want these to be images out on the web, they wanted them to be searchable and indexable, which meant that they had to actually be opened up, and the PDF had to be analyzed to find the words in it, to do text recognition. And so they wrote a MapReduce program to do that. They ran it over the weekend, basically, on EC2, and got the results back. They didn't have to go buy 100 large machines, because these were 100 large EC2 machines that they used. That's quite an investment for something you really just need one time. They're not going to have to do that again. They digitized their entire backlog. And so instead of taking months, or instead of requiring a lot of money, they could just sort of pay Amazon this one-time fee to use their infrastructure for a weekend, basically. The other one is Netflix. So like I talked a little bit about, Netflix had a database error that impacted their business. They said IT infrastructure ops is not what they're really good at, so they outsourced it to Amazon. Amazon provided them a cost-effective infrastructure outsource, so they're expandable, so Netflix can just add more capacity as they need it. They don't actually have to go out and build a new data center. For example, whenever they get 100,000 more users, they can just tell Amazon and get more machines. The other advantage is that Amazon is already global. They have data centers in multiple countries, so Netflix didn't have to do that themselves. They didn't have to go and build a data center in London. Amazon already handled that for them. Same for Asia, things like that, right? They have several different geographically located data centers in the United States as well to provide low latency. And so Netflix doing that would have incurred quite a bit of overhead because fundamentally they don't have the scale necessary for multiple data centers. They just needed low latency times. And then higher availability and reliability than Netflix could realistically achieve. So Amazon has a lot of expertise in infrastructure, a large footprint, and they've invested in redundancy to the degree that Netflix really wouldn't be able to match it. And it doesn't make sense for them to, right? It's not a core competency. So data sets. What we'll see here in a minute is Amazon stores a bunch of publicly available data sets on S3. Some are pretty big. So the one that we'll be examining is 2 terabytes. And Amazon stores all these and allows you to access them for free. So we'll be using one of these data sets to demonstrate Elastic MapReduce, which is an Amazon Web Service offering. It's basically Hadoop in the cloud. There's some other data sets you could use. So if you're thinking about a project, you can use the Common Crawl Corpus, which is a body of information that's all web crawl data. It's more than 5 billion web pages, and it's 541 terabytes. The 1,000 Genomes Project is a detailed map of the human genetic variation, and it's 200 terabytes. We'll be looking at the Google Ngrams, which are word groupings from Google's Digital Library Initiative. So some years ago, Google actually went in and they built machines that could turn pages and digitize books, and they went into libraries and just started digitizing the collections. So this is the data set that resulted from that, and it's 2.2 terabytes. And what an ngram is just a grouping of words. So we'll be looking at the 1 ngram. I think they go up to 3 or 4. And a 3 or 4 ngram means it's just 3 or 4 words put together to make one record. So you would look at the 2 ngram to see how many instances of who's there were published in 1998, right? That's 2 different words that would be together as one. In our case, we just want to see how many what were the top trending words by decade. That's actually what we'll be doing. So we don't care about the couplings or the groupings of words. We just want the individual word. So like I said, we'll be analyzing the Google Ngram data set. We won't be doing 1,000 genomes. So getting started. So if we look at what you'll probably see whenever you go to AWS is like what I've got here. And so you'll see you can create an account up here in the top. So that's actually what you'll want to do. The free account's pretty much the same. It just allows you to do some free usage things, but it'll be the same sign-up process. So you just come in here as a new user, give it your personal information, and payment information, and then you'll be off to the races. I'm not going to walk you through that because I already have an account, and it should be pretty straightforward. So you'll see here in my other browser, this is what you should see once you actually sign up. Is you'll see a sign into the console, and so whenever you sign into the console, you see its whole list of services here. So you see EC2, Lambda, Elastic MapReduce is right here, EMR, and so that's what we'll be using. But before we can get started there, we actually have to go into EC2. So go ahead and click EC2, and you'll see some information here. This is kind of your dashboard. And so what we'll want to do is over here on the left, we want to go under Network and Security, we want to go to Key Pairs. And so you can see I already have a key pair. You probably won't. The key pair is how you actually access your Amazon Web Service instance whenever you load it. So we have to create a key pair. You can name it whatever you want. You can see here I'm naming mine OU Test. I'm creating it. And you can see it downloaded it for me. So this is my cryptographic key. And so you can see that's my private key. It's generated it, and they have a copy. You use these so that it's more secure to access your instance. So it basically makes it harder for people to get on your AWS accounts and to access the machines that you've launched. So once you've done that, once you've downloaded it, it'll download to your downloads folder. If that works for you, just leave it there. You can move it to wherever you want. We'll need to access it later, so keep it. If you have any problems, you can come in here and you can create a new pair if you ever need to. So now let's use the console home in the top left to go back. And let's go ahead and make an EMR instance. So go ahead and click EMR from your page. So you can see here, this is in my history. I had a cluster. We want to create a new cluster. So go ahead and go to Create Cluster. We can name it whatever we want. I'm going to name it Ngrams. We want to disable termination protection. Basically, termination protection means that without jumping through hoops, you cannot turn off your instance. We want to turn it off. We do not want it after we're done, so you don't need termination protection. If you're a big business, you'd want to use this because it would keep people from accidentally deleting instances of machines that your business users were actually on. In our case, this is just going to be a one-time thing. We're just going to use it for a few minutes. We also don't want logging. We don't want to have to worry about managing that. We don't really need the logs. You can add tags. You don't need to. So you can see here, here's our software configuration. We're actually using an Amazon Hadoop distribution. So Amazon has gone in and they've optimized a version of Hadoop. You can see it's based on 3.6.0. That's their runtime. excuse me, they've optimized it to run on Elastic MapReduce basically. We don't need to mess with it. We want to leave it with the default. You can see there's some applications that are already going to be installed. So by default, Amazon's going to install Hive, Pig, and Hue for us. We can remove these, but we obviously don't want to. We could add other things. So if we wanted to install HBase, Impala, Ganglia, or Hunk, we could install those as well. And it just launch those for us automatically. We don't need to change the file system. So in the hardware, this is where you can specify the size of the instance that you want it to launch and how many. And we can always add things later, but we can't remove them. So I'm actually going to stick with the defaults, the extra large. If you add more core and task, it'll do things faster basically. So if I added 10 core machines, it would launch those, it would finish my jobs faster. So you can see here I've got the instructions that you can follow along with that I'm going to upload. And I'll be copying and pasting out of this as we go along. Alright, so that all looks good. Security and access, we want to use the key pair that we just created. So you can see OU test is here. I want to use that. And that will allow me to access it. If you don't put a key pair in here, you will not be able to get onto your machine. We don't need to specify any bootstrap actions, no steps. Let's go ahead and create the cluster. So this will take a few minutes. You can see it's starting, it's provisioning. You can see the steps down here as it goes. So it's pending, so it's setting things up. So it hasn't actually started these steps yet. So after it launches it, it'll do my setup for Pig, Hive, and Hue. And this generally takes 1 to 3 minutes. Alright, there you go. You can see it's made progress now. So I have my master has been stood up. I have its access information, and now you can see it's bootstrapping and provisioning my 2 instances. So now we're making some progress. So what we'll need to do in order to access this, you can see the SSH right here. So this tells you how to connect. So it automatically knows I'm on Mac Linux. If you're on Windows, these are the instructions to get you connected to it. So you'll need to actually download PuTTY because Windows doesn't have an SSH client default. Here's your link. Open it up. Just basically follow these instructions, right? Category, click session, host name, put in this information. Now the advantage to using this is you can actually just copy and paste this. This is actually the name of my instance you can see here, right? The public DNS. You'll need to click authorization and use the private key file. So you need to follow this step, otherwise it won't let you in, and then dismiss the security alert. So I'm on a Mac, so my instructions are a little shorter. I can just open up terminal. So I just search for terminal. And you can see here, I just need to copy this command. And I need to find that file that I downloaded. It's in my downloads, and it's OU, so there it is right there. I actually think I just want that. And so I want to, this is fine. That's okay. That's a normal error. Alright, so you can see here, I'm going to have to Alright, so what I just did is I changed the permissions on that key file. Let's see if that worked. Yeah. Okay, so that worked. So if you're on a Mac, you actually have to run that command I just did. So you have to do sudo chmod 600, and you have to find your file. So that's what I just did here a minute ago. So I ran sudo chmod 600, and then it was in my downloads OU test folder right here. And that changed the permission so that it would accept it. Before I did that, it wouldn't allow me to use that key file because too many people could read it, basically trying to protect me from myself, which is great. Once you do that, it obviously worked. The command that I ran from Amazon allowed me in. Again, if you're on a Windows machine, follow the instructions here, and you shouldn't have to do any of that. If you're on a Mac, do what I just did if you encounter the same issue. Alright, you can see here my cluster is launched, my steps are completed, so I'm good to go. I can start running my instructions. So basically what I need to do, I've already gotten in, I need to create a table. So I need to go ahead and start up Hive. And I can copy this command. So you'll recognize this command from some of the lecture. So we're creating an external table called English 1 grams. This is defining the structure. So the gram is going to be string, year is an integer, occurrences is a big integer, the page it was found on, and the book it was found in. We're doing a row format delimited fields by a tab stored as a sequence file, and here's where we're getting it. So this data set is stored on S3, and sorry, I copied that twice. I wasn't quite patient enough. So you can see here on the first copy, I created the external table. I just copied and pasted it into my command line here, and it said okay. It created that table. Took 2.33 seconds. You can see I did it twice because that table already exists, so it didn't allow me to do that a second time. Okay, so it created that external table. It did 5 columns representing the fields in the data set, and we want it, whenever we bring in the data, to store it as a sequence file. And we told it where that data is. So this is a data set out on S3. That's what this prefix is. And so AWS knows how to read that and manage it. So what we're going to do is we're going to actually normalize the data out. So we're going to create a table to store the normalization data. So this is actually just creating a table like we saw in that example. Now you can see here you don't have to hit enter if you're on a Mac and you paste it because it's already given me that new line. So, and basically, okay, so I just created a table called normalized. It's got 3 columns, so string for gram, year, and occurrence, because those are the 3 things that we care about from this set of information. Now what this command is doing is it's actually inserting into that table. So like in the lecture we saw, insert overwrite table. So it would overwrite all of the data that's in the normalized table if there was any. And we're selecting, and here's the function. So it's going to lower, it's going to put everything lowercase in gram. It's going to bring back year, and it's going to bring back occurrences. And it's selecting it from our 1 grams table. So this is the table that we created just up here, right? This is the table right here, English 1 grams. This is actually pulling data from our table, and it's going to do it where the year is greater than or equal to 1890, and it's going to do it where it falls within these bits, right, where the gram is this bit of information. So what we're trying to do is we're not looking for punctuation, we're not looking for any kind of special characters, things like that. So we're trying to filter things out here. Yeah, so the reason that we're doing past 1890 is because there's less data before that. It's noisier, and we're lowercasing to normalize it out. All right. Oh, sorry, I didn't actually copy it. Let's try copying it and then pasting it. All right, so it's launching a job. We don't have any reducer here. You can see it's just mappers, so it's not actually doing any analysis. It's not actually pulling any information out. It's just running map jobs to extract data. It's not doing anything else on them. And so while this is running, you can see it's running fine. I'm going to go ahead and go down. Excuse me. And so the next thing that you can see that we're going to do is we're going to actually create another table by decade, and we're going to query the table that we just made, the normalized table, and put it in the by decade. So what we've done is we've created a table that's reading information straight out of the in-gram data set. So that's what it's doing right now, is it's reading the raw data and it's putting it into a table we made. We're actually going to take the data from that table and put it into another one because we want to do some more analytics on it. So what we're going to do this time is we're actually joining the table on itself, which I know may be a little bit confusing, but that's because we want to be able to compare the data, right? So we want to be able to do a total, so we're doing a substring. So what the substring is doing, and if this is a little bit confusing, it's okay, but fundamentally we're saying I want to look at only the decade. So I'm looking at the first 3 characters from the year to bring back something like 18.9, because I don't care if it's 90, 91, 92, 95, because I'm looking at word by decade. So I want to take all of it from all of those decades, and I want to compare it as 1, right? And so what I'm going to do is I'm taking that, I'm parsing it, basically I'm dropping a little bit of that information, and I've got a group by, and I'm taking that, I'm taking the decade that I'm getting from here, right? as decade. So that's where this is coming from, is this subquery right here. And I'm also summing the occurrences while I do that. So I'm summing the number of times that a word appeared in that decade. So that's what this substring does, is it takes it and it parses it into decades, and it finds all of the instances of a word for that decade, and it totals them up. So that way I'm taking the number of occurrences I see, how many times I see that word, I'm dividing them by the total number of words. That's the other side of this. How many words were there total? So what percentage did this make up? So the result that I want back is the word the. Maybe it was 30% of all words that appeared in the decade 1890. And that's what I want back for this column right here, is occurrence over total. So I want to see how many times did the appear in the decade, and how many times did every word appear? What was the number of total words that appeared in a decade? You can see, because I'm summing here, I have to group by down here. So I'm grouping by, and in this case I'm grouping by the total as well. But I'd have to group by the gram and the decade. The total would be more optional. So that's the key thing to keep in mind here, right? Is what we're trying to get out of this. We've normalized the data. Now we're calculating the usage ratio using another query. You can see here my reducer is going, or my mapper is going. There's not going to be a reducer. You can see it tells me the cumulative CPU time, so I'm using several different instances, so it calculates the time differently because I get a bunch of different CPUs. These large instances on Amazon have quite a bit of CPU power. You can actually see that. We can navigate back to the home here. We can look at EC2. Now we can see my running instances. So you can see here they're extra large. Here's the information about them. Here's when they were launched. Here's where we'll terminate them later. We don't have to worry about that right now, so let's just leave that as is. So you can see we're at 38%. So we're going to do this table next, and this one will take a little bit as well. So keep in mind that the smaller your instance, the longer this is going to take. So this is going to take a few minutes, and the larger instance costs more, but it's not going to take as long for our commands to execute. So if I had doubled my number of worker nodes, if I had 4 instead of 2, this would execute much faster. And actually I can add some. While we wait, I just go ahead and do that. So you don't have to follow along with this part of it. I'm actually just going to go through and I'm going to try to add some more instances, nodes to my cluster. Let's see, I'm not really sure. So I'm going to resize here. I'm going to add 2 more to make it go faster. So you can see it'll take a little bit for me to get those extra nodes, but as soon as those come online, thanks to Hadoop, I'll actually get a pretty significant speed improvement. So let's just go ahead and let that keep going. But again, keep in mind, you do not have to do what I just did. I just wanted to add some more horsepower to my cluster so that we wouldn't have to wait as long on my jobs to execute. See, it's trying to resize it here, so it's pulling the information, it's pulling the extra instances, so it's in the process of resizing those, so it's allocating me some more machines. We're at 66%. So the reason this takes a while is because it's reading a large data set and it's pulling a lot of information into Hive right now. So it's still working on that. This is still working on that. It's trying to get me some more instances. So we're almost 80% complete. Okay, so it looks like these are coming online. So my 2 other instances will be up soon. They're initializing. So it's allocated them for me. So the next job that runs should be quite a bit faster, twice as fast actually, because I'll have twice as many machines, twice as many worker machines. Obviously, as you recall, the master node doesn't run any actions. It just manages the execution. So right now I basically have 2 machines that are doing work for me. So I'll bump that up. And you can have as many as you want. Just keep in mind you pay by the machine. So if you encounter any kind of issues, it makes more sense to have fewer machines if you're kind of playing around with it, if you're not really sure what you're doing. It makes a lot more sense to have a smaller cluster, because then you're not paying as much while you're waiting, right? While you're trying to figure something out, while you're having a problem, you're not paying the same rate, because you pay whether your cluster is doing work or not. So if I left this running all night, but I wasn't doing any jobs on it, it cost me the exact same as if I ran it all night and I had it doing 100%, right, if I had it doing work. So you do not want to leave these running without anything going on, basically. You don't want to leave these running unattended because it'll just keep charging you, basically. All right, you can see that job's almost done. So now I'm going to copy this query. So again, this one's calculating our occurrences by decade. Excuse me. So unfortunately, I didn't get those online in time to see a speed boost from this, but that's okay. Oh, sorry. I actually have to create the table first. I skipped that part. So I got to create the table by decade. So here we go. So I created my table. And now I've got to insert override into that table. And so there we go. Didn't copy it. Let's try that again. Let's copy that. Let's try running it. There we go. All right. So now I copied my statement successfully. It's loading up my job. And I think my cluster is all online. So I've got all my worker instances up and running now. So this is going to go a lot faster. You can see here, I've got 17 mappers and 6 reducers. So it's broken it up based on my block size. And you can see it's a pretty large job that we have running. And the reducers are because we've got the summing going on here, and we've got the grouping of a substring and a sum going on here. And you see my map is going pretty quick. This isn't going to be an apples to apples because it's pulling out of a smaller table. So every time we're doing this, the table is getting smaller and smaller. So the initial data set, we were pulling out of a few terabytes. Now we're down into the hundreds of megabytes or gigabytes. So it's getting quite a bit smaller, but you can see that job's really flying now. And you can also see here, sorry I moved off, that my reduce is moving somewhat in parallel. So it's starting a little bit of the reduction as it's able. But my map is already almost a third complete, so this won't take very long because, again, I have a pretty big cluster. So the next thing that we're going to want to do, we can get down to calculating the changes by decade. So that's what we're doing here, right, is we're calculating the top trending words by decade. So what we'll see in some cases are like fascism. Fascism appears in one decade where it wasn't a word that was used very much in the decade before. So what we're doing is we're calculating these against each other. So we've made the table, right, we've got our table for by decade, and now we're actually bringing some results set out, and we're extracting and doing some analysis on this. So we're going to say we want to pull out the word, the decade, the ratio, and then we want to do the increase here. And so our ratio, excuse me, was calculated up here, or this is our ratio. You can see it knew that because we called that in our table. It's the third one. We didn't name it here, but because that's the third column, it knows to put that there. So we already calculated the ratio in this job. We're just pulling it back out, and then we're comparing the ratio against itself to get the increase. And so what we're doing is we've got A as one decade and B as the next decade. So we've said I want to look at it and I want to step the decade up each time, right? So I'm saying decade equals 1900s and above. Ratio has to be greater than 0.001% because we don't want words that are noisy, right? That only appear a few dozen times but have huge swings because they didn't appear the decade before. As it states here, this is an arbitrary number. It just seems to work pretty well. Here's how we're getting the decade before and after. So we're saying a decade is -1. So this would say I want to compare 1900s to 1890s. That's why 1890s doesn't appear here, because we don't have any year before it to compare against. So we're saying a decade is -1, and B decade is the actual one that we're comparing, right? That's the increase. So you can see A ratio and B ratio. So the A ratio is the -1 right here, because it's keying off decade. And the B ratio is the +1. So in this case, it'd be the 1900. Our job's probably done. Nope. Okay, so it's running another step. So you can see we have 5 jobs here that's actually broken it out into. So we've actually already completed 3 of them, looks like. Oh no. We've completed 2 of them. Okay. Okay. So the other thing that you can see here is that it doesn't actually export it. So we're going to have to export this to a file. So while this is running, I'm actually going to stop here, and then we'll have one last short one that'll show the last job. So I'm just going to let this run and resume after it's done.